Welcome to our last RN Pharma workshop. It's been 2 exciting weeks of workshops and a conference, and this is the final one that we have here for today. We are ending it on a high note, and we have an excellent workshop for this afternoon. So with that, I think we are all set. Omar, I'm going to go ahead and pass it over to you. I'm going to turn my screen share off. And if you want to kick yours on, I will let you know if I can see it.
Okay, thank you very much, everyone, for having me today. My name is Omar. I am currently a graduate assistant at the University of Florida. So the topic of today, as you might know, we talk about visualization in R. And we will talk specifically about ggplot2 and plotly. And also I'll show you a very cool package called BER. So I'll show you how can you leverage actually functional programming into your plots. So the outline for today, first I will just show you the data set that I will give you some examples on. So this is warfarin data, which is a PKPD data. You don't need to know much about PKPD, but this is just the examples that I'll be showing you today. And then I will walk you through ggplot2. And also then I will show you how Plotly would work to create interactive plots. And finally, I will show you how to use BER. So again, the idea of the whole workshop is that to give you an insight of the different things, what you have in your toolbox and what you can leverage. But then you can just like be creative and use these tools as any way as you want. But I just want to give you very cool examples that I usually use the most and I found it to be most useful. And we are having interactive exercises today. So we have about 6 exercises, and each one of them will take about 5 minutes before I will go ahead and discuss the solutions with you. Also we have a material here. So this is the GitHub repository. If you don't have, for some reason, don't have access to Posit Cloud, I also copy and paste this one. And also I pasted the slides here, and if you need some references to ggplot later, I think the cheat sheet on RStudio website is just the best way to get started with ggplot. And also we have the Plotly documentation here, and finally we have the BER cheat sheet. So with that said, we will get started with the first part. So for the data itself, again, this is PKBD data. So if you want to see how this data has been ranking, I think I have. If you want to see how this data has been ranked, so this data has been obtained from NetMixer package, which is a very popular PK modeling package in R. So here I just like loaded NetMixer and Tidyverse and PMX tools. And this is how this data has been wrangled. So originally it was just like called warfarin data. And I just split it to be more visualization friendly. So I split the PK and the PD. And also I made the combination of PKBD. And the last thing I calculated the exposure here. So a few notes about visualization in general, if you want to prepare your data for visualization. So if you have things which are strings, like if you have a column like here in warfarin, if I showed you how this data set looks like. So actually, let me go ahead and open it directly from here. So if I have something like this column here, sex. So originally in the original data sets, I believe this was set as characters, right? So the problem, if you used this column directly as characters, you may have different order in visualization. So let's say I want to have like 2 columns or 2 points on the x-axis, and I want the first one to be male and second one to be female. If you have your data not formatted correctly, you may have different order, and it would be more hard to set this up. And also for columns like this one, so for the IDs, it's also better to record it in a different way other than just keep it numeric, because just all of the visualization will consider this as numeric variable, but this is actually not numeric. So you just have to keep this in mind. So at the beginning, it's better to just set your factors. So for here, for ID and dependent variable ID, all of these things, you better set it as factor and make sure that you have the correct ordering of them. So how you can know the ordering to just check this out? I already like manipulated this data set. Let's say here for orphan PK, I can say glimpse, and I can say orphan PK. So it will show you here that like ID has been set to a factor. So this is good. This is the correct thing that I want to see. And of course, this is already ordered because it was just numbers from the beginning. So it doesn't have a hard time to format it. But if you have other factors here, like sex, maybe it's not correctly formatted in the way that you want. So maybe you can just like type here summary and see the correct ordering of it. So here, this one is formatted to have females at the beginning and then males, right? You have in females, it says 57 rating points, and for males you have 194. But we see from that is that if you're going to plot, always females will show up before males, right? And here also for this variable here, you'll always have the low weight will show before the high weight, right? So it depends how you want to order things, but if you have a lot of categories, you really need to care about that. You need to care about how you will set your factors, right? How you will order them. And my last tip here, if you want to reorder your variables, probably the easiest one to reorder them is to use one function from cat package, which is fct level. So we already loaded tidyverse. So this function is actually loaded as you have loaded tidyverse. So tidyverse will load for you for cats, and it will also load ggplot and most of the packages that we'll be using today. All right, and the last thing also I want to say is that intuitively, if you want to like plot two different variables, like if you have, let's say, if you want to plot the concentrations of males and females, you might be tempted to have like one column called males and have all the concentrations of it, and one column called females and have all the concentrations of it. But this is not how visualization would work in R. So in R, you would always need to have all of the x-axis in one column. So if I need this dependent variable, I cannot have this column to be split into two, one of them for male and one of them for female. So you have to have all of your variables, all of the x-axis in one column and all of the y-axis in one column, right? You cannot just like split them into multiple ones. And we will show how can we then stratify them using ggplot and plotly. All right. So this is again about the dataset, just a PKBD dataset. We usually are interested in, for the pharmacokinetics, we're interested to see the concentration over time. So usually you will see the concentration, the dependent variable on the x-axis, on the y-axis, and the time on the x-axis. And for the PD data, we are interested also in the same variable, but this is still will be the dependent variable. And also we can plot it over time. But another thing at the end, the ultimate goal is just get the exposure. So on all of the previous data, we have just like a time series data, but the exposure is just like counting the total concentration, the total area under the curve of these subjects. All right, so one important note to talk about is that there is little to no interplay between different visualization approaches in R. So if you just like starting from the basics of R, you would have seen some functions like plot. So in R, there is something called the base graphics. So we also have the grid-based methods, which ggplot is one of them, and we also have plotly. So any of the visualization methods that we will be using, they just like don't have, you cannot just combine different functions. So for example, here one of the most plotting functions in R is just like plot. So if you just like go read the documentation for this one, you'll find that this one, it belongs to base graphics, right? So you cannot just like use different functions from different methods. You have to know what kind of method that you're using, so you can just like use the same functions from ggplot. And if you're using other package, which is just like doing something that says, okay, I'm just like specific package for pharmacokinetics, you need to know what kind of visualization engine that it's using. Maybe it's ggplot, maybe it's something else. But it's very highly encouraging. I just encourage you to just try to stick to one of them. And I think ggplot is like, if anybody is trying to learn R, the main thing that actually brought people to R is just to use ggplot, right? So this is just like I think the main thing that people use R is just to if there's a single thing that people would use R, they just like use it to just harness the power of ggplot. So ggplot2, again, as I told you, ggplot is really, if someone is just want to learn R for no other reason, probably ggplot is the reason that people would come to see, would come to just like learn R for just this single package, because it's just a wonderful package, and it just like can do any kind of visualization that you want, and you have a lot of control over it. So ggplot is built on the idea of called the grammar of graphics, and most of the graphics these days are actually built on this theory. So you can just like break any kind of plot that you're having into three parts. One part is the data, right? And the other part is the aesthetics, right? And the other part is the geometry, or the geometric layers. So how this would work in ggplot. So the first thing in ggplot, you have to define a ggplot function, right? You just like have to write ggplot and then pass the data frame. So anything between this kind of brackets, you can just like replace it with the real code that you have. So you just have to pass your data here, and then you have to set your mapping. So this is where you define your aesthetics. And in aesthetics, you just like try to bind everything in your data to something inside of the plot. So if you have like, you need to define, typically you need to define the x-axis, maybe y-axis, maybe you can also set color, maybe you can set fitting. So everything will be bounded to your data set, and it will create it, it will take it dynamically. So if you set the color equal to one of the columns in your data set, it will just like color them dynamically for you. And so this is how you define the data and the aesthetics. But then you have to define a layer, geometric layer, to be able to see the plot. And you can define as many geometric layers as you want. So if I go back to this screen here, I just want to show you quickly what do we have typically in ggplot. So ggplot is already loaded, but if it's not, you just like have to write ggplot2, and you can just like type geom and underscore, and you'll be able to see all of them, right? So these are the geometric layers. You can just like go ahead and explore each one of them. So we have geom AB line, we have here like box plot, you have like contour, count, so you have a lot of them. And each one of them would have slightly different aesthetics. So you can just like go ahead and open the documentation, and let's say I want to see the geom of, let's say, error bar, right? So as you can see here, we actually have geom error bar, and we have geom error bar H. So let's just like look what's happening inside of them. ggplot has a very nice documentation when it comes to aesthetic. I think it's very comprehensive. So you can just like go down here and see what are the essential aesthetics that you need to have. So here you need to pass either X or Y, and you have to have, if you're just like decided to go with either one, X or Y, you just have to have a minimum and maximum. And I believe the same also will be done for geom bar horizontal, right? So you can just like go ahead and explore all of the geometric layers to see what we have here, but we really have a lot in ggplot, and you can just do a lot of things with them. And another layer that you may be using is stats. But the idea of stats is that you don't always have everything that you're going to be plotting inside of your data. So maybe you're doing like something like box plot, or you're doing like bar chart for counts. But actually ggplot make it easier. So you usually don't need to use stats layers. You probably will be just having all of the parameters that you need to pass from in the geometric layer. So if you want to have like counts and you don't have counts in your data set, or you want to calculate some kind of regression or something like that, you don't really need to use the stats layer most of the time. So 99% of the time, you don't need to use this layer. And another thing is faceting. So faceting is how you can create like layout of multiple plots, and we will see how we work with this. This will be important part of the topic of today. And another thing is coordinates. So coordinates is just like functions that you can manipulate your coordinates with. So most of the time, I will be talking about the Cartesian coordinates. You don't need to specify this by yourself, but you just like have some kind of set of coordinates that you can play around and see how can you adjust them. And another thing is position, and also position is similar to stats. You don't have to specify it directly unless you really have to do something which is very unusual. But most of the time you can just manipulate the position from the geometric layer itself. And another thing is a scale. So in ggplot, scale can be divided into two things. One of them is that you can have just the scale of the plot. So you can access that using just like scale and scale of the x-axis. So scale x continuous and scale y continuous. So using that, you can specify the limits from where is the beginning of the plot and what is the end. And also you can just scale the colors, right? If you have, if you specified some color variable, you can just like also use a scale, let's say scale color, maybe scale color manual, and you can change your colors from this kind of scale, right? I also will show you some examples for this one, but just like keep in mind that scale in ggplot can go two ways, either for the axis or for the color range. And another layer is annotate. If you want to add annotation layers, if you will just like want to add text or something like that, you can do that. And I also have an example for this one. And the last one is theme, and how you can just change the theming of the plot. If you want to change the color, if you want to hide something, if you want to increase the font size, all of that you can do it with just the theme function. All right. So let me look quickly in the chat if we have questions here. No. Okay. So this is everything that we have regarding the basics of ggplot, and I really want to show you now some basic examples of that. So the first thing you need to do is just load the ggplot2 package. And this is how it works simply. So in the data set that I'm using here is just war exposure. So I just have to pass the data set, and I need to set the X and Y. So here, the X-axis is the categorical variable that I have. So it will just like put it this way, and I need to also specify the Y variable, which is going to be the area under the curve. So this line will just like create a blank figure. And after that, you just had to add a plus and add the layer that you want. So the layer that we want here is geom_box plot. So this will create the box plot for us. And as you can see here, maybe at the beginning you started to get intimidated that you have a lot of parameters to change. But actually in ggplot you have a very good defaults, so everything by default looks very well. You usually don't need to change the themes or need to worry about the coordinates or anything like that. All of these things can come up later, but most of the time, everything will just work out of the box for you. And another example here. So to just like try to scale the examples a little bit, we typically in pharmacokinetics, you need to create the spaghetti plots. So we need to stratify the data by some kind of variable. So how can we do that? So we will do the same thing. We will pass our data and we set. So I've not been expressive here, so maybe I can repeat this one. Maybe here, maybe minimize that. Just to make sure that. And let me press this here. So this one is here are my data, and this one would be my X, and this will be my Y. Okay. So again, this line will just like create an empty plot, and I need to start adding the layers, right? So here I set color equal to ID, and what is the idea here is that I need ggplot to start to stratify all of the lines they have by ID, so I can see different colors for each ID. Another way to do it, you can just like say group. So group will just like stratify also the plot, but it will not show you different colors. So it really depends if you want all of them to be the same color, if you want them to just like scale by different colors. So again, if I'm running only this part without the plus, it will just like give you the blank figure, and then I can add the layers. So if I just like run these together, it will just like give me the figure with the points. So it will look like that, but as you can see, it's not connected. So I can add another layer, which is the line, and I'm running it all together now. So now I have two geometric layers. I have the points and I have the lines, right? And you can see here, this ligand shows for each different subject, I have different color. So I hope this is clear. If this is not clear, maybe we can pause a little bit and have questions if someone get lost in that. So now I want to talk about faceting. So in ggplot you have two kind of. Okay, you want me to maximize the windows? Thank you. Control Shift 1. Okay, thank you very much. So for faceting, faceting is just like to create multiple plots based on a variable inside of your data set. So this is not a way to create combined plots, but just you need to have different, like you just have some kind of variable that you need to break with. So let's say I have sex, males and females. I want to create one block for males and one block for females, right? And there are two ways to facet in ggplot. You have facet wrap and facet grid. So facet wrap will just like use all of the data, and it will create you some kind of just a wrap, right? It will just like create all of the figures and put them side by side, and then you can define if you want them to be like in different rows and columns, etc. But also we have facet grid. So facet grid will take all of your data and it will just like create them in a form of a matrix. So I'll show you a few examples about them later on. So how can you write the facets? So you can facet by as many variables as you want, but you typically use some kind of a formula to do that. You can just like think of, if you're using facet grid, you need to use the formula in this way. So you have to have the x's and the y's of the facets. So if you write it this way, like put facet underscore grid, for example, and you just like write it this way, you have var1 will be splitted on the x-axis. And if you write it this way, you have var1 faceting on the y-axis. And you can actually have as many of that as you want, so it would keep combining them. But again, if you're using just facet grid, it will create them as a grid. So you'll keep the X and Y. But if you just like use facet wrap, it will just like create a combination of everything and show you the results at the end. So I think I have a question here. So the question here is, how can you ensure the same subject would have the same color in the entire report? So that's a good question. So if you want to do that, you can just like use the scale function. I think if by default, it makes sense to me that it will not change if you just like use the defaults. I think ggplot will do the defaults for you. But if you want to be sure, I think the safest way is to if you're not changing the number of subjects, you can just like scale. I'm dividing by color, so scale color manual. I think this would work. So as far as I know, I think the question, I don't know if the question is just like, if I want to ensure that they will be the same, I think if you have the same number of subjects, they will not vary during the report. But if the question is that while you're working, you're dropping some subjects, I think you need to have something different. So I think it's, yeah, definitely, I think it's an advanced question. So I think the question is that if I have some data set that has, let's say, 10 subjects, and later on I have it like, I dropped some of them and I focused on 5 subjects, is this the question? Okay, you may lose some subjects when you have to take log. So this is a little bit of a technical question. So usually when I take a log, I usually add some kind of, if I have a lot of zeros, I add, it really depends on the kind of analysis, but I usually add something to just avoid, to just like remove the NAs. But if you do that, you can just have, okay, thank you very much for the answer. Actually, yeah, thank you. You can specify the, I actually copied this piece of code here. So one of the solutions that we have here is that you can specify for each subject the value of it. I don't know if this can work actually as a data frame or not. But here I can see the solution. I think this could work also if you need to specify exactly how they would be. So for this one here, if you have in your data set, you have, I think this is coming from the iris data set. But I think this would be converted to either like subject 1 or subject 2, and you can specify the curves. Is that right? So I think this could be a solution if this would help, but I think this would be a lot of work if you have like here 33 subjects. So I think another solution that I would be doing here is just to have a way to keep track of them. So probably I would have like I generate a random palette, and from this palette I would have each subject mapped to one of the IDs, and I would just like keep this palette fixed during the analysis. So it will just like, I would just use a very similar solution like the one posted in the chat, but I think it will be just like better to have all of them written at the beginning of the analysis and then pass them to a ggplot. I hope this is a good answer. So I just want to give you an example of faceting. So this will be just the same kind of plot that we have, but we need to facet them different panels. So I can just like specify here facet grid, and I'll just make it to facet by the x-axis. So you just like have to pass here this variable here is 6, and it will show you the plot in this manner. So you can just have better exploration in that regard. And here also another line I added here is just turning off the theme. So you can just have just inside the theme function itself, you have a lot of parameters, and one of them is the ligand, the position. So you can just like set this to none, and it will turn off the ligand for you. And another way to facet is just like to use wrap. So if you have only one variable and you just like, in this typical case here, you have IDs and you want to have just you can just like use this line here, facet underscore wrap, and you can just set the ID. So this will pass for you all of the IDs. It will create like a new plot for each one of the IDs, right? And if you still need to use the color, of course, you can kept using the color equal to ID in the aesthetics layer. So this is the time for the first exercise. So what I want you guys to do is just try to use the faceting. So we will have facet with two variables. One of them is weight categorized, and the other one is sex. So try to create these two figures here. One figure is going to be this one, and the other figure is going to be this one. So the same, it will be the same exact code, but you will just like be either using facet wrap or facet grid. And yeah, share with me if you have any hardship, or you just like find one of them is going to be better than the other. So we'll have about 5 minutes, and you can just try your hand with this one. Okay, and feel free to put all of your questions in the chat. I get the last comment here. So regarding colors, can we use a variable from data frame to specify colors? Yes, sure. So the example actually that we have showed by ID, it's the same thing. It's I don't know if this is your question here. So just something like that. So ID is actually a column inside of the data set. So if you said like color equal to ID, it will just take the ID and create the colors for you, if this makes sense. Yes, you can change the gray colors and fonts of the facet grid. So I believe this will be a function of the theme. So if we just like to close this one, I think the shortcut is Control Shift. So it's not really at top of my head how to change them, but you can just like go to theme and find which one of them is going to be corresponding to this one. I think it's going to be one of these. So panel background, or one of these. I believe it would be related to the theme of the facets. Yeah. So again, we're having this exercise here. So just like you can find the exercise here and type your answers here. So I see some people are sharing very good resources to R, and definitely encourage you guys to read these references. Definitely ggplot2 book is a very useful one. So yeah, thank you very much for sharing this one. So one of them is about, again, the colors. So one solution here, if I'm just like using the iris dataset, if you have like a dataset that has two variables, to just make it easier to find how to do this one. So if I just like created the iris dataset, and I can set the aesthetics to be equal to let me turn this off quickly so I can see the data. This one. So what you want to do is that you want to, let's say, create a scatter plot, and you want the x-axis to be equal to this variable, and you want the y variable to be equal to this one. So the last thing that you need to do now is to divide them by species. So you can set the color equal to species, right? And then what you need to do is specify, let's say geom point, and the solution that has been shared. If first, let's see this one. So this one will give you a plot like this, and let's say you want to have some kind of special color for each one of these categories. So you can just like scale color manual, and instead of having them inside of the data frame, you can just like have them here. So you can have, I believe the solution was to make the values in like this. So you can say we have the species equal to this one, and I can say this is going to be red, for example, and you can say here, I'm not sure what is the other one. Let's say Virginica. Say, so this way you can just like change the colors. So I have to specify all of them, I think. Let's see, I have still errors. Yeah, so here it goes. So if you want to make it like just like want to specify the colors directly, you have to just write them in this way. I do believe maybe you can just like put them in a different data frame, but I don't really know. But I think this is the way to go if you want to have them as I just like different colors for each category that you have in your data. All right, I think I missed a lot of questions, and I think already time is out. So let's go back here. Oh yeah, time's out. So I promised to go back to the questions, but just like go through this one. So I hope you guys found the answer. Okay, so anybody's having any trouble with the question? So I think it was pretty easy one. So you can just like have this exercise here to go through it. I think it was straightforward. So we just like here created the traditional plot, and then we just like create the facet trap using this syntax here, using this formula. We wanted to have two variables, so we can create the facet trap this way, and we can also create facet grid if you want to change it. It's pretty easy to see which one would be more visually appealing for you. So we can also change this one to be like that. But as you can see here, this is good for exploration, I believe, because we know that in this category, if you have low weight and female, this category does not exist. So maybe you need to change your data a little bit if you want to, if this category is if this variable is derived, and you need to find another split, or maybe if it's just like a variable that you cannot change. So you can, it's good to know actually that you have a missing category in this place. All right. So I think I took more time than I need. So for the other one here, the other exercise is going to be very similar. But also I will just like do the same kind of plot, but we have more than two variables. And also I want you guys to try this one here to pass margin equal to true to see what this is going to do. So simply this would actually have a margin in the facets, and this will actually create a combined plot. So you don't only have all of the variables that you have specified, but also you have a combined plot for all of the categories all together. So go ahead and try this one. I think I would just like give you only 3 minutes for this one. So go ahead and try this one and tell me if you have any problem. All right, so I think this would be good for this one. So this is really the code that it should be the answer. So the idea is that you need to create the figure as normal, and then if you want to have like two columns for two variables, you need to write them this way. So again, this is like an equation, a formula. So you just like, if you want to stratify the x-axis by two variables, you can just like write them this way, and you can then specify the margin. I believe also the margin, you can specify the margin either by the x's or y's. So I think the margin is also very useful if you want to just like have everything combined all together. So as you can see here, the x-axis has been divided into two parts. One part is going to be for the sex, and the other one for the other variable, which is the age. So I think this is very useful. And also here, we can see actually the margin has been calculated automatically for each for each one of the ages for each subcategory. So I think it could be very useful. Yeah, so I will just move on for the sake of time. I think we have only 1 hour left. So another thing which is very important that actually most of the people using ggplot will take time to adjust is that most of the time you need to create a very complex plots that has a lot of different variables together. So ggplot actually allows you to override the aesthetics that you have defined globally. So what I mean by that is that in this kind of code, we have selected this kind of data set, and we have set aesthetics, the x to time and the y to dependent to dv dependent variable. So with this kind of code, any kind of other layer will keep having this kind of x and y. But how about you want to have other geometric layers, and some of them are going to have like different variables, or maybe you need to color by different variable or something like that. So in this situation, actually ggplot allows you to override the aesthetics to something else. So here I didn't actually, here actually this one, I want to actually show you this one because I think I forgot to mention that. But if you are going to set aesthetics, let me just like create a new block here. So how you are specifying the color is very important. So if you're going to specify the color inside of aesthetics, it's going to map to the data set. So it will automatically color everything inside of your data set by this kind of this color, right? So I'm gonna specify color equal to one of the variables, let's say 6, right? So this way it will just like take this variable and it will color each one of them by that. But if you want to have the layer itself having color red, so you can just like have it this way. So this way will create a line which is red, right? So this is just like important to know that anything inside of the aesthetics will be mapped to your data frame, but anything outside of it will just control the behavior of the figure itself. So what I want to show you here is that I will be actually merging 2 different data sets in the same figure. One of them is going to be the PK data set, and the other one is going to be PD data set. This kind of figure is very commonly shown in some kind of papers. So in this figure, we're going to combine the PK and PD data set. So actually, I have not only created, I changed the colors or something like that, I actually have overridden the whole data set. So in this line here, I have used warfarin PK data, and this will be reflected in this line. So this layer here will actually inherit all of the aesthetics from the global environment. And after that, you would have the geom line. So this one would actually take all of the new aesthetics. So you're passing a new data set and you're passing new variables, right? So these variables are having the same name, but actually it could be different variables. And this plot is going to be a little bit complicated because we need to like have 2 different axes to them. So this actually solution is not very intuitive, but this is actually the best one I found. So as you can see, actually this plot, maybe I can just grab this one to show you what does this do. So let me paste this here, and let's run this one. So this actually plot is having 2 different axes. So you have actually I missed the ligand. Yeah, this is correct. So you can just like have 2 different relations of the drug in the same plot. So I think if we zoom this plot, it should look correctly. Okay. Here we go. So you can just like have two different axes, and to do that, I just like had to work around it. And the way this would work is that you have to just change the mapping of the axis, and you have to multiply it by some kind of factor. But as you multiply the axis by factor, you really have to also divide the main data set, because this is just how it would look like. So the idea is that you multiply the axis by some kind of factor, and also you have to divide by that factor the original variable that you're having. So anyway, it's just like not very uncommon to see, but I just like wanted to show you that you can have many different data sets in the same plot, and you can keep overriding the, you can actually override anything in the aesthetics in every layer that you're adding. So we now have another exercise here. So we are going to use the main function I want you guys to see is geom polygon. So geom polygon will allow you to actually have some kind of drawing around the plot. So you can specify some kind of range and you can plot it. So probably the most difficult part in geom polygon is to actually have the coordinates that you're going to input. So this is the figure I'm opting to have, and yeah, most of them took some time, so I believe it will be difficult to just like finish everything in 5 minutes. But I actually modified the data a little bit for this exercise. So this exercise, just use the data frame that has been filtered here. So use this data frame to create only a single subject. All right, so we just type filtered subject to have only subject ID equal to 1. And we also did some calculations here, and this will be the coordinates of the polygon. So go ahead and try to create this one. At least I would say in 5 minutes you can have just like this polygon has been set, and you can have like this figure that looks this way. But again, just don't worry about this one. I will go over the solution of it. So give it a try, and let's see how it goes. So we have a question here. What does dv divided by 4 is doing? So the idea is actually you can change the calculations in your data set dynamically. So what this is doing is actually you are dividing this variable by 4, right? So you have, let's say, you have a data point which is equal to 4, and you just like divide it by 4, so it will be equal to 1. So it's really not something that you're doing like for calculations, but the idea is that you are trying to refine the figure in a way that would create for you 2 axes. So what it's really doing, it's dividing the whole column by 4, but this was not how it was meant. It was meant to just like refine the axis in this way. So we multiplied the axis by 4. So if you want to make the figure looks correct and the points are correct, we have to divide this one by 4. So just like balancing both sides, we have to multiply this one by 4. We multiply the whole axis by 4, so we have to divide the data points by 4 to just like having them equivalently. All right, so let's look at the solution. I just like copy that to walk over it. So again, we just like did some kind of manipulation for the data, and this line is again just like mapping the data set and creating the geom point and geom line. So this will inherit from this data set and to inherit everything. Then we need to create the polygon. So a polygon, again, we would just, as mentioned in the question, we would just using this data set that has been set called points. So the idea of a polygon that it will just like pass the coordinates in sequential manner and to draw some kind of figure for you to draw a polygon. we are going to set the aesthetics here. We are going to set the fill and the color. By the way, you can always use it as COL, or you can just like make it as color, like the full word. And also we specify just alpha here for visibility. So for this part here, this will create what I wanted to more careful when you do the. Okay, so this will create just the figure that I asked for in the exercise. And this will just like create the polygon this way, and you can just like create it. You can just like play around and see if you want to have different shapes or different areas. So it's just like you have to find the right coordinates, and it will create this one for you. But you can also do like more fancy things. So I think it's a good opportunity to show the annotation layers. So the annotation layers can actually you can have a curve or you can have text. So again, it usually takes some time to just like find the right combination of everything. But here, this code will actually create like a curve for you, and it will create some kind of text that tells you just whatever kind of text that you're passing. So here I'm just like passing the Cmax. And the other thing is that we can just like create a line also to specify where the Cmax is. And also actually inheritance works for also the theme. So I would actually change the theme here to classics theme. So this will actually turn off everything in the middle, and it will just like have this kind of default theme that you can be using. But then you can actually override it again and use another theme function to just remove everything, to just remove the ligand. So we can specify the fonts for everything that you need this way. So this is usually useful because most of the time you can have like specify one kind of default theme, or maybe from another package, and then you can pass all of the parameters that you want for this theme. So I think it's quite just like useful to just like use one of these default themes, and then just refine it later the way you would like. All right. Let's see if we have any questions. One question is that I don't understand why we have more data points on the polygon than those specified in the points of data frame. I didn't get exactly the question. So I don't know. We actually, in the polygon data set, we have only 4 points. So if you just like, let's start this off again. Let's say you have, let's say I just like opened this data set called points. It's only for 4 points here, right? And polygon is just like you're drawing this shape. So I have 1, 2, 3, 4. So this is how I draw with it. I just like specified I want the X to be here and Y to be here. And also I wanted the X here and Y here and so on. And what is the difference between color and fill when you write it inside of S and when you write it inside of geom polygon? So I'm not sure if it will make a difference. No, it will make a difference. So in aesthetics, it will always give you some kind of mapping to the data set. So I believe if we created fill, actually, let's try this one. So no, not right, because if you like make it this way, like fill equal to sex, I think it should separate two figures. But again, they have the exact same, but we don't have this aesthetics inside of the data set. So if I have it inside of this data set, I have another 4 points, and one of them is called sex. It will just like separate like 2 different polygons. But also you can just like write it explicitly here and say the fill equal to blue, for example. If you write it outside, you just have to specify the color. It cannot be something else. So if I come here and I specify fill, I think you can write it the same way, but this way you cannot write it the other way around. You cannot say sex, for example. This makes sense. All right, now we move on from ggplot. I will try to be quicker this time because we need to finish in about 30 minutes. So we now will move to another kind of plotting system called Plotly. And Plotly is actually allows you to have some kind of interactivity. So I think it's just better to show you what does it do. So Plotly will give you this kind of interactive plots, right? And this is very useful not only if you're creating a dashboard, but also if you're having some kind of exploration that you're trying to do. So you can go ahead and you can zoom in, you can just like double click and zoom out. You can select some subjects. You can, I think you can do it the other way around. So you can, I think, press shift and turn off a few of them, or you can I think if you press control, you can just select a few of them. So I think it's very useful. And yeah, Plotly is just like very wonderful package if you want to have some kind of interactivity. And I think it was mentioned in the chat that you can be using like one function called ggplotly. So if you have any kind of figure that you are creating using ggplot, you can always just like type ggplotly. So this function here, you can just like pass any kind of plot that you have. So let's say this figure here, I just like call it P, and I can save it. Right, and here I can just like for ggplotly, I can say ggplotly and pass P. So this will just like create the interactive plot for you. So you don't have to learn much. However, though, in Plotly, usually you have some functionality that usually does not translate very well with ggplot. So I really highly encourage you to learn a little bit of Plotly. I'm definitely not an expert on it. But I think it's just very useful to know some commands and some ideas of Plotly. It will be very useful if you want to change it, and if you want to change some parameters in the data. So actually, Plotly has very similar concept to ggplot when it comes to the idea how you're thinking of a plot and how you're thinking of geometric layers. So instead of having geometric layers in Plotly, you're having what is known as traces, right? So you can just like add as many traces as you want, and also you can override the you can just like override the global variables as much as you want. So the syntax is totally different from ggplot. So instead of adding different ports, you're going to be pipe it. So like passing the data set. And now to write the aesthetics, you just like have to write it this way. You don't have a function called aesthetics, you just have an X and Y. But you have to put this tilde here if you're referring to one kind of column in your side of your data set. So you just like have to say X tilde time and Y tilde dv. And also if you still want to specify by color, you have to say tilde ID. And then if you run this code, if this line of code by itself, I think it will just like create an XY plot with points. But if you want to be more specific, so it just like has some kind of defaults by itself. So I think it's quite user friendly. But if you want to have more of refinement, if you want to specify a specific type by yourself, you just like have to pass these arguments here. So again, you will also find a lot of different things in the documentation of Plotly. You can just find the documentation of this function, and it will tell you what kind of other types you can be using. So here again, I want to have this scatter plot to have both points and lines. So you can just like write it this way. And the other thing is the layout. So the layout is also equivalent to themes in ggplot. So if you want to change the title, if you want to change the x-axis, you just like have to write it here. But again, in Plotly, you are piping the plot. You create the main plot using this function here, plot_ly, and you have to keep piping what you're having. So either you can use this pipe or the other pipe using like this syntax, right? So you can use this pipe or using this one. Okay, and I think this is one of the most interesting thing if you're doing some kind of exploratory work, that you need to be able to really see, like this data is not very big, but let's say if you have a lot of points and you want to see exactly what are the parameters of each subject. So maybe you can change the hover in Plotly. I think this is very useful functionality here. So in this plot, you can actually have changed the hover inside of the main function itself. Like you can just like have this function and say write the text and just like paste this line of code here. But I did it in this way in particular to show you that you can actually keep adding traces and you can keep modifying the traces as you go. So all what I did here is just like added this line of code from the previous plot. So remember in the previous plot, if I'm hovering, it will just like give you the X and Y coordinates on each point. But if you added actually traces, you can have some kind of more information. So what this line is doing here is that I'm updating the hover, and remember that this is going to be HTML. So I'm updating the hover to have subject ID, and then I'm creating a break, and then I'm passing the time point, which is the x-axis, and then a break again, and then the concentration, and I'm passing the variables that I want. Again, break and age and weight, right? So here I'm just like having all of these variables dynamically created from the data set. And again, remember that as if you're using Plotly, you have to pass the tilde before the text if you want something to be coming from the data frame itself, because otherwise it will probably find it in the global environment. So you just like have to have this kind of tilde in front of anything that has which is actually coming from a data frame inside of Plotly. All right, so with that said, we're having a new exercise here. I will give you 5 full minutes for this one. So for this one, we need to replicate the same figure that I have in the previous slides. So just to replicate the same Plotly figure, but we will replicate it with the pharmacodynamics data. So you can do that with this data frame here and just like map the x-axis to CP and the y-axis to PCA, and then try to modify the trace as much as you like, right? So just like if ideally I want to see it in this manner, so you have the ID, the concentration, PCA, age, and weight. But again, I just like the idea is to give you an idea how it works, and if you can just like modify this kind of trace, you will be able to see what's happening here. Okay, so I'll give you 5 minutes, and yeah, tell me if you have any questions.
So Omar, there is a comment by Libby saying that you cannot use ggplotly for all the functionality of ggplot. So not all the functionality that in ggplot will be converted to plotly. So it's a good comment in there for people to be aware on the usage.
Yep, that's right. So again, this is the reason why we are like creating the figures here using Plotly. So yes, also in my experience, I think, yeah, that's very good comment here. So not everything will translate well between ggplot and Plotly. So I think Plotly is well developed package, but just like, I don't know, maybe for some kind of technical reasons, not everything would translate using the ggplotly function. So yeah, it's always worth it to just like go and learn a Plotly if you want to do some kind of interactivity figures. But yeah, just like it's a shortcut, you know, if you have some kind of shortcut to use ggplotly and it would work for you, that's great. If not, then you just like have to run through Plotly. Yeah.
Another question here is for the tooltip, the hover, can you use data in the data frame that is not part of the plot? So let's say you have another column that has text or something else. Can you use that information there?
Yeah, sure. So actually the data here is coming from the data frame. So all of the things here like ID and concentration, all of these things are actually coming from the data frame. So as we saw in the last, in this slide here, so all of them are coming from data frame, and you just like have to pass the tilde here to be able to retrieve it. So the ID, this one of course is not coming from data frame. This is something that you hard coded. But everything else is just coming from data frame. So yeah, sure you can do that.
There was a question regarding the um, bigger than PR, smaller than sign, the breaker that you have there. Someone did not understand that exactly what that is.
Yes, that's a good question also. So Plotly is a JavaScript package, like it's meant to be running on a browser, and that's one of the reasons why this slide actually is running in a browser. So it's, you have to, if you want to write any kind of formatting, you probably need to have some kind of HTML formatting inside of the figures. So this one is just like an HTML syntax. This one is just like a line break, right? So VR is for break. So if I omitted this one, maybe I can show you this one quickly. So if I omitted this one, it will have like the line continuously going. But if I want to break them down, just the hover works as I want. So I have line break. But let's say I removed few of them here, it will just go continuously. So so just run this one. So as you see, like I don't have line breaks anymore. So it is not an R syntax. This is an HTML syntax. But again, HTML is just like simple language for formatting. This is the idea. If you want to format anything inside of Plotly, you just like have to use HTML formatting. This is the exact same figure that we have seen before. So I just like wanted you guys to try this out. So very simple figure, just like use Plotly to create the figure and just like set the type to scatter and the mode to lines plus markers. And then you can just like have just like set the layout to create the figures like axis names. And you can update the hover. This is the main part that I want you guys to try to just like add trace and make it to just like update the hover this way. And again, all of these parameters, all of these things which are unquoted like the ID and CP, all of them are actually inside of the data frame. So they're just like mapped dynamically. And you can just like, this line actually you just like to make the figure having like good size. So I just specified the width and height here, right? So this one just like to create good visualization. But yeah, that was it, and I just like move on for the sake of time. So also one other thing which is interesting in Plotly, which is actually difficult to see in ggplot, is that you can have 3D plots, and actually there is a lot of plots in Plotly that you cannot generate in ggplot. So you can create surfaces or contours or things like that, which is like having some kind of 3D figure. So I think this is very useful if you're having you're trying to do some kind of exploration and you're trying to have some kind of 3 variables in the same plot. You can, I think Plotly is a very nice tool to use it in R. It's a little bit difficult to make 3D plots in R. So the syntax is just the exact same thing. You just have to pass the extra axis, which here in this case the Z axis. So you just like have X, Y, and Z, and you can just have I want to split them by color, so I set the color to be equal to species. And again, everything with the tilde in front of it, it means that it's coming from the column. It's coming from the data frame, one of the columns of the data frame. And next, one very cool part of Plotly is that you can create actually subplots. So subplots is different from faceting, that in faceting you have one kind of variable which actually stratify all of the figure with some kind of variable. But subplots works differently. So subplots is similar to the functionality in cow plot or patchwork. So it will just like combine different plots together. So here in this case, actually, I just like, this is just for demonstration, but I'm having here many different plots. So I have here this plot is going to be a box plot, just like some kind of dummy variables. Here also I'm again plotting the iris dataset, and here I'm having also another plot for just random dataset. So I'm just like having 3 totally independent plots, totally different data frames, totally different shapes, and I can combine all of them in a single subplot. So just like to show you how it would look like. So I just like have to pass subplot and put everything in the list. So I have 3 plotly figures. I have A, B, and C, and then I have to pass. I can change the layout to resize it again. So just like it looks good, and here it goes. So this is how it looks like. I'm sorry. So I have here. This is the plot A, and this is the plot B, and this is the plot C. And as you have noticed here, so you can actually name the traces, right? So again, the trace is like a geometric layer, and you can in Plotly you're allowed to actually specify the trace name by yourself. So here in this case, if I write it this way, it will specify the traces of the figure in this kind of manner, right? So it will specify the ligand for the traces in this manner. And if you write it this way, if inside of the main plotly function, if you passed name equal to the trace name that you want, you can also add this to your ligand. So actually, I think it's very flexible if you have like some kind of subplots and you have a lot of traces, a lot of shapes, and you want to specify for each group in each one of them, you want to specify a specific name, you can just like do it very easily from Plotly itself. And even if you have different traces and you kept adding different layers, you can also specify the name of each one of these traces. So if you just like can look at here, I have just passed in the main Plotly function, I have trace 1. So this is for the first shape. And here I created named traces. And again, here for this figure, this one is a little bit more complicated. So for each trace I have added, I created a name for it. So this one has trace 5, 6, and 7, right? So this is how it would look. So for each one of these figures, you can have, sorry, for each one of these figures, you can have the traces. So I have here trace 1, and this one here is going to be, this is again named by the variables inside of the data frame. So it will tell you the species of the flowers. And this one here, you have, it says this is trace 7, and this is trace 6, and this is trace 5, and so on. So I think it's very nice functionality, and inside of the subplots function, you can actually specify how many rows and how many columns that you want. So you can just like create them as a grid. All right, so moving on to exercise number 5. So this is the one just before the last one. So just like create this kind of figure, I think it should be pretty straightforward to do. So just like get the Warfarin PK dataset and create 3 box plots. And in each box plot, you just like stratify by the variable here, which is either sex or age category or weight categories, right? So go ahead and give it some time. And I think I will just like give you about 3 minutes for this one. So yeah, go ahead, and I am happy to take any questions.
Omar, there's a couple of questions. One, how can you remove the X and Y values from the tooltip, the hover? Or if you can.
I'm not sure if you can, to be honest. Let me check here if I. you need to remove the, I'm not sure. Maybe I think there is definitely a way, but yeah, not on top of my head. So let me check this one here. If I create it over, yeah, it will keep it in. I definitely believe there is a way, but yeah, I'm not on top of my head right now.
Okay. Another question is, can you put multiple plots from different libraries? Like let's say you have a plot from ggplot and a plot from Plotly. Can you put them with using subplots in the same plot?
So I think subplot, if you passed, I think subplots will convert ggplotly figures for you to Plotly. But it really depends. So this is one thing that I said at the beginning of the workshop. So most of the packages don't have good interplay between them. So it depends on the package that you're using. So the package is creating for you Plotly figures, then you can combine them. But for ggplot, if you want to combine different ggplot figures, I think the best option would be either to use other packages like cowplot or patchwork. So they work exactly the same like this function called subplots and Plotly. You can just like create a grid of different plots, and you can have actually even like different sizes of each columns and different rows. But I think, yeah, the short answer is no. You cannot combine different figures from different frameworks. So you just have to stick to either you're creating all of your figures at the end as Plotly figures, or you want to create them as ggplot figures. And the answer at the end will depend if the package that you're using is giving you ggplot figures or not, or giving you something else. So you just like cannot combine different frameworks.
Another question is, how could you have these three plots that you're showing in the example have the same y-axis?
Same y-axis. I got the question. So these figures, or
Yeah, I think that, yeah, the figures, the previous figure. I guess it doesn't matter, right?
So to put all of them in the same axis, you mean like in the same single panel?
But I think the question is y-axis have the same range, I guess, for the y-axis. I think that's what. Sorry, what?
Yeah, sorry, the same scale. Yeah, so I want all of this y. Also, I have to specify the scale myself. Okay, yeah, that could work.
Okay, so you mean to specify the scale? So I think this data set is actually different data set, but if you want all of them to have the same scale, you mean like in this figure here, this one scale ends by 8 and this by 100. So you want them to have the same scale? Is this the question?
Right, yeah, y-axis. But no, yeah, like all of them to be minus 5 to 5 or something like that. Or yeah, just to, if I mean, I have different types of data that this will kind of apply to. I could specify the range, right? Yeah, like the scale, the y-axis, the scale from minus 10 to 10 or something that would cover all of them, right? Yeah.
Yeah, sure, you can do that. So if we are talking about different data sets, so I think in this case, these data sets are not the same, right? So that's why you see some kind of a huge discrepancy between them. But if you're having like the same data set and you're just like try to put them in different way, I think I show another example with per at the end, so I think it should help a little bit to answer your question. But the idea is that if you're having the same data range, most of the defaults will be quite similar at the end. But if you're having like different data sets, probably they will look a little bit different. But also another thing to also make sure I covered all of the points. So if you want them all in the same panel, you just like have to add different traces here. So if I'm having, let's say, same data set here, I created this data set here with these 3 columns, and I can keep adding as many traces I want on top of each other. So I believe also if you want to add different data frame in Plotly, you can just like pass the data variable and it will just change it for you. I'm also not on the top of my head how to change the scale if you're having different data frames and maybe most of them are not going to be aligned. But definitely there's a way if you want to change the scale to range for all of the data that you have added. So for this exercise has been very simple. So you just like have to create these 3 plots. So the idea is that we would create 3 plots. Each one of them is going to have the same data set, but we will have different mapping. So one time we have the x-axis to be sex, and the other time age cat, and the other one is weight cat. And you can just like combine them in a plot. But as you can see, this is a little bit tedious if you're going to have, let's say, 20 variables, 20 covariates, and you want to create box plots for them. So that's the reason why we will see BER next. So what is BER? Again, BER is a big topic. I hope really to get to the advanced questions in the chat at the beginning of the workshop. But what BER is going to do is that this is a function for, or this is a set of functions that you can use for functional programming. This is a little bit mouthful, but the idea is that if you have like some kind of a list or a vector of different objects, you can apply some kind of function for them. And probably the best source to understand how this would work is just like to refer to the advanced R book. So I think you would find this one online. And the idea of BER is that instead of repeating a lot of code, you will just like try to minimize the code as much as possible. So everything which is repeated, you can just like put it and contain it as a function, and you will just like map everything inside of the list in a function. So I will show you how this would work in by a few examples here. So what this example is doing here, I'm getting all of the variables that I want to create a density plot for. So let's just break this down a little bit. I would have first the function called BER. This is one of the tidyverse functions, one of the tidyverse packages. And what I'm going to do here is I'm going to use the function called map. So I need to map all of the columns inside a data set to the figure, right? So I will be passing these columns to the figure, and this figure here will create density plots, right? So I need to just select the columns to make it easier to pass them to BER. And after I just select the columns here, so I selected here 3 variables: age, weight, and dependent variable. And then I will set how my template will be. So my template here will be, I just like passing again the same data set, and I want to pass the columns, right? So this will be like a placeholder here, and to just like map each one of them sequentially. So these 2 lines of code here will create for you 3 plots, okay? And the same is here. This one is a little bit more complicated, but maybe you don't need to just like filter the data this way, because maybe this is a little bit counterintuitive. So if you want to create like a box plotter in this example, I will just have the names of the columns I want, and I will do the same. I will create a template, and I just like have to put this template in an enormous function. And in this one here, I will use this syntax which is specific for ggplot. I will use the .data, and I will just like try to pass the name of the column inside of the dataset, right? So this would actually do something. It would do the same thing like this solution, so both of them would work. But it's up to you which one you find easier. So each one of these will create 3 plots. This one will create 3 plots for the density, and this one will create 3 plots as box plots. So actually, I don't have them on the slide, so maybe it's worth it to just like run them quickly. So again, if I just like run this one, it will create for you 3 figures, right? So you reduced the amount of code that you want. So imagine if you have even more variables. Imagine if you have like 10 variables. So all what you need to do is just like pass all the column names here, and you can create like 10 density plots very easily. So another thing I want to show you very quickly is, again, BER is a very big topic, so I will just like stick to the basics here. So maybe you can create leftover plots. So what this line of code here, let me grab this quickly. So let's start a new one. So what I'm gonna do here is that I'm going to create also 3 plots, and this will be 3 box plots, right? So I'm gonna run this code, and this will be like 3 plots saved in a list, right? So if I want to see them, I may print them here, like plots, right? So this will just like print all of the plots I have. And what if I want to save them? So Plotly is BER is having a function called walk. So what walkers do is that, unlike map, it will not give you back a list. So it will just like do something like read a file or save a file or something like that. So in ggplot, you have a function called ggsave. So you can just like save all of the plots that you have if you have all of them stored in a list. So either if they're coming from the map function of BER, or if they are just like a list of multiple plots that you have created, you can just like easily use something like walk to just like save all of them. So if I just like need to turn off this this one here to show you what's going to happen. So if I just like run this code here, and you can have a look at the files I have in my workspace. So if I run that, it will save the figures that has been created, right? So I just like saved all of the plots, all of the code. I have reduced the redundancy, and I can just like save all of it in a very concise manner using the functionality of BER. So I think I have one last exercise here. I don't know if I think we are already on time. So maybe I can walk over this one by myself. So we want to create. So again, for Plotly, you don't have something like facets like in ggplot. So what if you want to create this kind of figure that you have in each panel, you have different ID. So in this case, you really have to grab each ID, and you have to create like a separate plot for the subject, right? So I think this is a very nice functionality if you're going to make Plotly figure. I think this would work if you just like use the ggplotly function, but I think if you just like want to have more refinement and more control, you can just use the map function. So what this code here is doing is this will actually create all of the plots that you have, and at the end, it will create a list of multiple Plotly figures, right? So if you run this port, it will run multiple Plotly figures, and each one of them is going to be for each ID. And at the end, you will combine all of them in a subplot. And I specified here that I need 5 rows, right? So if you run this one here, let me make this bigger. So I don't know why. Anyway. So I specified here I need 5 rows, and it would just like, what happened is that I split the data set by ID. So I have a list for different data frames, and each ID is having his own data frame. And then I would just like create a plotly figure for each one of them this way, right? And I will save them as a list, and I will pass it to subplot function from plotly, and it'll create this kind of nice figure for me, and I will keep all of the interactivity. So that was the main idea of today. I'm sorry I ran out of time, but yeah, thank you very much for having me today, and thank you for listening. I will just like, this is here my LinkedIn and my GitHub page. If you want to connect, I'd be more than happy to take all of the questions in the chat. I think I need just to save this chat, and yeah, feel free to reach out to me if you have any more questions. Thank you very much.